Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 9.6 and we're going to split this into three parts. So this is part A today. And it's on factoring trinomials. All right, so your warm-up is factor each trinomial possible. So these we've already done where they have a leading coefficient of 1. So remember we learned a little puzzle method here to help us. We wanted to think of two numbers that multiply to negative 50 and add to 5. So in this case, it should be positive 10 and negative 5. Those numbers are 5 apart and they multiply to 50. All right, so our factored form here is going to be m minus 5 times m plus 10. So remember, factoring a trinomial is like unfoiling the trinomial, okay? Going backwards. All right, so our little puzzle here would be 24 up top and add to 11. And the two numbers that would add to 11 and multiply to 24 are 3 and 8. So 3 times 8 is 24, and 3 plus 8 is 11. So if you're ever having trouble thinking of these, you just start with your calculator adding pairs of numbers that multiply to 24. So 1 plus 24, 2 plus 12, 3 plus 8, until you find the pair that adds to 11. Okay? So this is going to factor into t plus 3, t plus 8. Number 3, we have x squared minus 9x plus 15. So these are two numbers that multiply to be positive and add to negative. So we know that this is 15 and negative 9. Both numbers must be negative. So think of two numbers that would multiply to 15 and add to 9. And those numbers are going to be, let's see, 15 and 1 doesn't work. 2 doesn't go evenly into 15. 3 and 5 doesn't work. And then that's it. There's no other numbers that would go evenly. 4 won't work, and then 5, and we're back to this. So this is going to be prime. And then in our last one here, we want two numbers that will multiply to negative 36 and add to negative 9. Okay, so one of them has to be positive, and one of them has to be negative for this to work, and the bigger one needs to be negative. So we could try 1 and 36. Well, that's not going to be 9 apart. 2 and 18 will not be 9 apart. 3 and 12 are 9 apart. So that'd be positive 3 and negative 12. So this is going to turn into a plus 3b. Don't forget to put the b at the end of both. And a minus 12b. Okay. All right, that completes the warm-up. Down below we have, recall the general form of a quadratic equation is ax squared plus bx plus c. So in all of ours up above, we were doing the special case where a was always 1. So obviously that's not going to happen very often. All right, so previously we only factored trinomials where a had a value of 1. The real puzzle we are solving for factoring a general quadratic is what two numbers multiply to the a and c together. So up here should be the a times the c, and down here is still the b. Okay? So before it worked fine, we did 1 and c. So 1 times c was still c, but now we got to be careful. All right, so there are many, many ways to factor. Okay, we're going to do the box or the table method, the reverse of what we did before. Most students find this the easiest one to do. However, they're splitting the middle term or just guess and check of all the factor list. So if you like to take a look at one of those, you can check your book or Google those two things. Okay, so the one that's not in the book is called splitting the middle term. And it's a good method also. Okay. All right, so let's flip it over and see what we mean. So we have an example on the second page that says factor the quadratic expression 5x squared plus 12x plus 4. All right, so in this case, a is 5. That's the number for the x squared part. The constant term is 4, so that's our c value. And the linear term, the part with the x, is b, which is 12. Okay? All right, first, what two numbers multiply to 20 and add to 12? The 20 comes from the a and the c multiplied together, so 5 times 4. And the 12 is still just the middle term, so b. So we want them to multiply to 20 and add to 12. All right, well, we've been doing this one since last time, so this is 10 and 2. 10 times 2 is 20, and 10 plus 2 is 12. Now we're going to create a box just like what we did when we first started multiplying binomials together. Except our one change is instead of putting the outside of the box, the binomials, we're going to fill in the inside of the box. So the top left term gets the 5x squared. So 5x squared goes here. Okay. The C part, the plus 4, goes in the bottom right. And then we take our answers from the puzzle. Our answers from the puzzle are 10 and 2. And we write them here, 10 and 2. But together, these two are supposed to make the middle, the 12x. So I need an x with them. So this is 10x and 2x. All right? Now we've got our box. We're just going to use our box to work backwards and find out what were the binomials that multiplied in to make this box. Okay? So to get 5x squared and 10x together, we're just going to do some unfactorings here. So we're going to think of it this way. Look at these two together and say, what is the GCF of 5x squared and 10x? And the GCF of 5x squared and 10x is 5x. Okay? And then we go, okay, well, 5x times what would have made 5x squared? Well, that's going to be x. So that first entries had to be 5x and x. All right, now to get the next one, we'd say 5x times what would make 10x? Well, that's going to be 2. All right. Then we can look at the GCF of these guys. The GCF of 2x and 4 is just 2. And then we double check. So we take this 2 and we times it by x to make sure we get the 2x that's in this spot, which we do. And then we take this 2 and times it by 2 up there to make sure we get 4 in that spot. Okay, so everything checks out. And that means if I took the two binomials, x plus 2 and 5x plus 2, and multiplied them together, I would get our trinomial. Okay, you should always take a second and just check yourself to be sure. So if we look at this, the first real fast would be 5x squared. The outside would be 2x. The inside would be 10x. And the last terms would be 4. And then you can see 2x plus 10x would make 12x. So the better you are at FOIL, the faster you can check them to make sure that you did not make any mistakes. All right, let's flip it over and do a couple from the beginning. Okay. All right, so let's do some of these together. So factor each is our directions. So remember, all the stuff that we do is just scratch work to try to get to our answer. So we'll put the scratch work on here, but the final answer is the only thing that's needed. Okay. So first things, we need to solve our little puzzle. The top would be 2 times 7 for 14, and the bottom is 15. So it's going to be 1 and 14 will multiply to make 14 and add to make 15. All right, so we'll make our box. And the box is 2x squared and 7. And then we split the 15x into these two things, 1x and 14x. Okay? And then we factor. So we say, what's the GCF of these two? Well, that's going to be 2x, and it would leave behind x and 7. So 2x times x makes 2x squared. 2x times 7 makes 14x. Okay, then we look at the second two, and we say, what's the GCF of these? It's not much, just 1. Okay, 1 times x is 1x, and 1 times 7 is 7. All right, so our binomials are going to be 2x plus 1 and x plus 7. Right, and then you should always just FOIL them back together just to make a quick check. So first terms would be 2x squared. Outside would be 14 and inside would be 1. So 14 plus 1 would make 15x. And then our last terms, 1 times 7 would make 7. So we know we did it right. Okay. Number 2, same kind of thing. We'll make our little puzzle here. So two numbers that multiply to 12, 3 times 4, and add to negative 13. So I know they both need to be negative, or they wouldn't multiply to a positive and add to a negative. And they're just going to be 1 and 12. Okay, so I'll make my little box. Help me get my answer. The top left gets the first term in our trinomial. The bottom right gets the 4, and then we split the negative 13m, which is our outside and inside in FOIL, into negative 1m and negative 12m. And then we look at our box and do a little factoring. So we'll look at the first two entries in the box. The GCF of these is m. And then that leaves behind 3m. M times 3m makes 3m squared. And it leaves behind a minus 1. M times minus 1 makes negative 1m. Okay? And then we look at the GCF of these two, negative 12m and 4. And that GCF is going to be, well, let's see. We need to pull out a negative 4. Okay? And the reason is we already have a 3m up top, and we need to times it by negative 4 to get negative 12m. And then negative 4 times negative 1 will make positive 4. So the GCF was really, could be 4 or negative 4. We need to make sure it's negative so that all of our entries in the box match up correctly. Okay, so that's what I meant on the other page when I said always double check and make sure all the entries multiply to what you want. So n times 3m is 3m squared. M times negative 1 makes negative 1m. Negative 4 times 3m makes negative 12m. And negative 4 times negative 1 makes positive 4. So this one's going to factor into 3m minus 1 and m minus 4. Now remember, the part that I'm squaring here is the only part that is important. That's just your answer. The rest is just scratch work to help us factor it. Okay. Number 3. We want two numbers that multiply to negative 40 and add to negative 18. Okay. So that means one of them is going to be negative and one's going to be positive. Otherwise, they wouldn't multiply to a negative number. So the two that are 18 apart are 20 and 2. So we'll make our little box here. All right, we have 5y squared. This term goes in the top left. Negative 8 goes in the bottom right. And then we take our two middle terms. So negative 20y and positive 2y. They come from these two entries, and they need to add up to that negative 18y. So we have to put a y's with them. All right, we look at the first row, and we say, what's the GCF? And the GCF is 5y. And then 5y times what would make 5y squared? So that left behind a y on the inside of the parentheses. And 5y times what would make negative 20y? That should be a negative 4. Okay. And then we can just think, okay, well, negative 4 times what should make negative 8? So this had to be a 2 here. So the GCF for our second 2 was 2, and we left behind y minus 4. Okay, so 2 times y makes 2y, 2 times minus 4 makes negative 8. So that fills in our entries. Okay, so we just do a quick double check of everything. 5y times y, 5y squared. 5y times negative 4, negative 20y. 2 times y, 2y. And 2 times negative 4, negative 8. So I know my binomials are going to be 5y plus 2 and y minus 4. All right, one more. Okay, so we want two numbers that multiply to 12 and add to 7. So 6 times 2 on the top and 7 on the bottom. All right, these numbers are going to be 3 and 4. So we'll make our box. The quadratic term, 6n squared, goes into the top left. The constant term goes in the bottom right. And then we use the 3 and 4 to make our linear terms, 3n and 4n. Notice they add up to 7n. So the GCF for the top boxes are 3n. And then 3n times 2n would make 6n squared. And 3n times 1 would make 3n. And then 1 times what would make this 2 right here? That's going to have to be a 2. And 2 times 2n makes 4n there. Okay, so we can go through and just double check again real fast. So our first terms would be 3n times 2n, which makes 6n squared. Okay, and then we have 3n times 1, which makes 3n. 2 times 2n, which makes 4n. Those are our inner and outer. And the last terms are 2 times 1 for 2. So we know we did it right. Okay, so this is going to give me 3n plus 2 and 2n plus 1, and we're done. If you FOIL them together, we get 3n plus 4n, which is 7n on the inside. Okay, so we know we did it good. All right, so that gives you 4 problems to try yourself. If you're starting these problems and you have no idea what you're doing, that means when you were watching the notes, you're doing what some of you do in class, which is just copying stuff down but not trying to understand. Go back and watch again. I am going to look for your scratch work on this, so please make sure you have it on the page, and then we'll look at it. And the final answers are down here for you to check, so please do not just copy my final answers. I want to see that work. I want to see your table, and I want to see your little cross so I know what's going on. All right, I'll see you in class next time.